Now let us try to draw the region of this guy, okay? Suppose this is the coordinate. The function y is x minus x squared. If we define it as the function f, suppose, let us say, f is x minus x squared. Therefore, we know that it is x and 1 minus x here. So what is the y-intercept and x-intercepts here? 0 and 1, perfect.
0 and 1.
Very good. So the x-intercept is, and y-intercept is 0 here, and suppose 1 is right here. Okay, 0 and 1. So the graph will go through these points. Now, in the section chapter 5, right, you know how to sketch the graph. If x goes to negative infinity, this one will go to negative infinity, right? I mean, if we take x, go to the left, the function will be some point here, down below. If x go to positive infinity, the limit of this function will go to positive infinity, right? So, and another trick, the multiplicity of this guy here is 1, right? So somehow the equation will like this, and the multiplicity of this is 1, so it will cross, and then here at 1 is also cross again. So the graph should be like this. It's not very clear at the detail, but it should have the shape of this guy, right? So now you can do it this way to study it. So what is the maximum value of this function? How can we do it? How can we find the maximum value? In order to find the maximum, we need to compute the first derivative, right? It will be 1 minus 2x here, right? And we set it to be 0. Therefore, x will be
1.
1/2. Okay? So when you take a table to study this function from negative infinity to infinity here at 1/2, f prime here has a solution at 1/2. For x smaller than 1/2, this guy will be positive, right? And negative here, it means the function is increasing and decreasing. And this is a maximum value. We can determine the maximum value f of 1/2. It will be 1/2. We use this formula, is easier. 1 minus 1/2. What do we have here? Very good, 1/4. So now let us correct the graph here, okay? It's not a good. Okay. Let me make this bigger. 1, 2, 3, 4. Let us say this is 1. 1/2 is right here. Then 1/4 will be here. Then, okay, the maximum value is here. It's not a good draw, but yeah, you see it, right? And this line bounded by y is equal to 0. What is the line y is equal to 0?
The x-axis.
Perfect. This is y equal to 0. And another line at x is equal to 2. One and 2 is here. So at x is equal to 2, it should be like this guy. Okay? Wait. Okay. I think we've done this in class, right? Yeah. We've done that in class already. So the region is this guy. Okay? And now it is rotated. This region, and it is rotated about this axis, right? So if it rotated this way, suppose the region, it's not a, okay, the region is like this, right? And the axis equal to 2 is here, it rotated about the axis equal to 2. What do we need to know? And which formula should we use to find the volume? It is in 6.3, right? So, yeah, cylindrical shells, right? In that formula, we need to know the volume. It will be integral from, suppose, from the lower limit. It is here in this case is from A, right? Is equal to 0 to 1. Okay. And we rotate it this way. So it will depend on the variable dx. Do you have a question? Okay. Then the cylindrical shells formula tell us that, okay, it will be 2 pi, the distance, right? Pi r, fx dx. And what else? This is the height, and here is the thickness, okay? Very good. This is the circumference. This is the height of the function. And here is the thickness, dx, okay? In our case, the distance r, it means suppose at any point here, what is the distance of this point? If this is x0, then what is the distance from x0 to 2? Yeah, 2 minus x0. Very good. Do you agree? And the height of this region will be, at any point x0 here, the height of that will be the difference from the x-axis or the line y is equal to 0 to the graph here, f of x, right? And that is exactly the function here, right? Or let us, if we use the, if x0 varies, then this is 2 minus x. And here will be the function f, which is x minus x squared dx. Okay? We've done this in class already. Is it clear? So now, if we vary this question one more bit, if now it rotates about the line x is equal to 1, what do we have? If we rotate it here. Perfect. Then the only difference is the r here, right? The distance from the point to the origin it rotates. Okay? If it rotates about the x-axis, the x is equal to 1, then the volume will be integral the same thing from 0 to 1, 2 pi, and r in this case will be the difference from this point to the axis here, which is 1 minus x, and the same height, right? Same height, which is x minus x squared dx. And computing this integral is not difficult, so we'll not do it here. We just understand the idea, okay? In the real test, for this problems, I may not ask you to compute it clearly. I just want you to set up the integral. And I will state it out in the test. So you can set up it here, and you'll find. Okay. Is it clear? Yes. A question? Oh, yeah, yeah. So we're good, right? Do you want to do the first one? 5-8, okay. I think